The topic for this presentation is conduction in polymers. So, can you imagine polymers to be conducting? We all know few examples of polymers. Say the wires which we've seen shown in the figure here. Copper wire has a sealing on over it. That is a polymer. So it is for protection normally. In general, polymers are not conducting materials. They are non-conducting. They have wide band gap. That is, the energy gap between the conduction and valence band is really high. And normally they are used for electrical insulation. That is to prevent short circuits. So if you can see the conductivities of a few polymers, say polyethylene, it is on the order of 10 power minus 5 ohm meter to the power minus 1. Similarly, polytetrafluoroethylene is 10 power minus 18. Polystyrene is also higher than that. So normally we see that the conductivity is not so really good compared to uh, a normal metal or conductor or semiconductor, because they have very wide band gap and conductivity is always less. So this low conductivity has some drawbacks. Even though it is used for some insulation purpose, it also has drawbacks. So to be uh, more precise, we could say the most important drawback is the static electricity accumulation. Say what happens because of static electricity accumulation is we can have some damages in the internal solid state devices. Also, there is a polymer matrix composite which is used for the wings in airplane. So lightning strikes and then again there also we have this static electricity formation, and this leads to severe damage. So these are some of the drawbacks of having low conductivity, that is with the polymers. So how can we improve the conductivity of the polymers? It's a bit contradictory. Naturally, it is a non-conducting material and we know it has certain advantages. At the same time, as we already saw, there are few disadvantages as well. So how do we overcome this? We can try to make it conductive. So how do you make the polymer conductive? First thing is you can introduce an additive. Secondly, you can inherently make the polymer to have good conductivity. You can create polymers with good conductivity. We'll be looking at this separately, right? So introducing additives. Additives means it is understood already. We studied about a lot of composites and we also studied about polymer matrix composites. So we can have polymer as a matrix here and we can try to add some additives to it, say fibers, carbon fibers, etc. So you could see that you can add ionic compounds to the polymer to reduce the resistivity. So this can help to dissipate static charges. So there will not be any more accumulation of static charges. Secondly, conductive fillers, say carbon black. Now we have studied about this when we were talking about the polymer matrix composites in the previous unit, if you remember. So this carbon black, it also dissipates the static charge. Secondly, you can also have composites with carbon fibers as well as polymer matrix, which could result in high stiffness and improved conductivity. And then also you can think about hybrid composites. That is, you can have a combination of metal fiber and carbon or glass or aramid fibers uh, as the reinforcements on the matrix, which is nothing but your polymer. And this could really help with a lightning safe aircraft skins, which we saw as a drawback in the previous slide. So the picture here gives you an idea about the conductivity of insulators, semiconductors, metallic conductors. And if you initially see, if you talk about conducting polymers, you could really make them move slowly from the insulators level towards the metallic conducting level. You can have undoped polymers which are not not conducting, they are almost insulators, and slowly you dope them, or you can have some composite blends and all those things as seen in the blue line below the red one. There also it is possible to convert them, change their conductivity and make them as good as metallic conductors. So what happens when you introduce additives? Say the graph here shows that when you improve the filler content, that is filler here is either graphite or graphene, and the polymer matrix is nothing but PET, polyethylene terephthalate. So we have been talking about this PET when we had the discussion on the synthesis of polymers, addition, condensation, polymerization, if you remember, PET bottles, right? When we were talking about the condensation polymerization, right? So if you want to improve, we know these type of polymers are really insulators. So you can add graphite to it, and slowly when you keep on increasing the volume percentage of the filler, you could see that the electrical conductivity also increases. And again, the type of filler also matters. Graphene and graphite are two different type of fillers. You could see the impact when you change the filler, right? So the conductive fillers and fibers are used in order to produce a shielding against electromagnetic radiation. Even that is also feasible by using the conductive fillers. Fine. Inherent conductivity, the second type. How can you make the polymers inherently conductive? Some of the examples here are acetyl polymer. We just dope it with arsenic pentafluoride. So its conductivity reaches almost close to that of metals. Then polyphthalocyanine. There they have made cross-linking by special curing process, and then they have improved the conductivity of the material so that it has become almost semi-conducting. And polyaniline, PANI. This is really a very good material that it has found application in LEDs, light emitting diodes. I'll be talking about this inherent conductivity in separate slides after I upload this presentation. I'll be uploading the other presentations also. So stay tuned to know more about the inherent conductivity of the polymers. Some of the applications of these type of conducting polymers goes like this. It's not few, it's a lot. See, piezoelectric transducers, optical storage, where you have solid state photochemical reactions, then solid state devices like sensors, electrochromic display devices, ferromagnetism, magnetic recording, superconductors. We'll be talking about the superconductors also later. Then you could have uh, other things also like plastic batteries, right? Many other applications are possible. So you can refer to this following paper to get to know more about the applications of conducting polymers. So the beauty is even in 1998 they've predicted these are the applications for conducting polymers. And lately, now recent application, what I would like to talk about is the application in medical industry. You could see the conducting polymers application in tissue engineering and biosensors, even development of artificial muscles. So this is a device you could see when you switch on and off. I mean, you apply the electrical signal and you leave it off. When it is in off condition, it is straight. When you apply the electrical signal, it bends. So it is like our natural muscle. It gives the movement, mechanical movement by application of electrical pulses. And this is also possible by using conducting polymers. So the task for you is submit an assignment on any 3 applications of conducting polymers that is of your interest. Suitable references should be mentioned. And that is all here. I will continue more about the conducting polymers, that is by inherent conduction by doping. Thank you.